Hi folks, Glenn here. A couple of things I just want to clear up real quickly. This is from the old WebAssign, but it's still going to be useful for your future quizzes and tests. This is the ammonium ion, this is the phosphate ion. The ammonium ion and the phosphate ion are ions, but they're made of more than one atom. See these two capital letters? That's two different kinds of atoms. See these two capital letters? There's two different kinds of atoms because every atom, or every element, which is a kind of atom, every element has only one capital letter. This is by design, so that when you see two capital letters, you know that this is more than one kind of atom. Now, when the ion has more than one capital letter, then it's a polyatomic ion. That means you need to keep the whole thing together. NH4 is the name of this ion. I mean, we call it the ammonium ion, but you got to remember that the N and the H and the 4, these are all part of that name, all right? So it's like me, right? My name is Glenn, Glen. You cannot write this and expect someone to understand that you mean me. In the same way, you cannot write just NH and expect that someone will know that you meant this ion. You've got to have that 4, all right? So let me show you how this is done. You write the NH4, and then how many of these are we going to need? I'm going to use this number right here. I'm going to put it right there, just as I showed in my previous video about this type of work, this type of writing of formulas. And then now that ended up looking like NH43. But see, that's not his name. His name is NH4. I got to keep that together, and to do that, I use parentheses. I only use these parentheses because I didn't want you to think I was talking about NH43 because that's totally somebody else. This is somebody who doesn't exist in our universe. This is somebody who does exist in our universe, and I'm saying that there are 3 of them. What about the PO4? PO4. Here I've got the P and the O and the 4 all together. That's his name. PO4 is his name. Now, I only need one of them because this plus sign indicates a 1. I'm going to put a 1 out here. However, you do not need to put the 1 because just by writing PO4 here indicates that there is at least one of these here. I do not need parentheses here because there's no number out here trying to make you think I was talking about PO41, which is not what I was trying to do. So this is the correct way to write this formula. The systematic name for this compound would be to name the polyatomic ion here, ammonium, and to name this polyatomic ion phosphate. I know you have had other naming exercises using phosphate and perhaps using ammonium on WebAssign also. Okay, what about this guy here? See these dudes right here, HPO4? Those are together. That's his name. So I'll put a K here, potassium. I'll put that 2 right there instead. And then I'll put HPO4. I don't need parentheses here because this 2 indicates that there are 2 of these K's, and K is his name. There are 2 of them. I mean, there's not going to be a confusion here. What about here? HPO4. Well, I don't need parentheses either because I only have 1 of them, so there's no confusion. This is called potassium hydrogen phosphate, also known as potassium phosphate dibasic. Here, let me just write the usual systematic name. Potassium hydrogen phosphate. Now, there is also, just to make this more complete, this compound also exists. See, there's only 1 potassium, but there's 2 hydrogens. This stuff right here, this is called dihydrogen phosphate. So you would call this potassium dihydrogen phosphate. You only use the prefix di, mono, tri. You only use those prefixes for molecular things, not for ionic things. I know what you're thinking. You're thinking, isn't this an ionic compound? Yes, it is. However, this part of it, just this by itself, this is dihydrogen phosphate. These atoms are stuck together with chemical bonds that are not ionic bonds. So this by itself is molecular. Even though it is an ion, this by itself is molecular. So we're allowed to use di just for this. We cannot use di here. Why? Because this potassium, has nothing to do with the molecular part of this. This is the molecular part. But the K and this and this together, they make an ionic compound. Yes, this ionic compound contains a molecular compound in it, but together it is an ionic compound. This is kind of like your car, right? Your car is something that you call a car. You do not call it furniture. However, there is furniture inside your car. So this is your car. There is upholstery and very nice furniture inside your car. These L's are the upholstery, the furniture, right? And you do not call your car furniture, right? When you talk about washing your car, you talk about maybe you going to a car wash where they spray with water and they may use some type of soap or detergent, but what they do not use is shampoo. You do not shampoo your car. However, you do shampoo the inside of your car. You shampoo maybe the upholstered surfaces if you're a fancy person. So this is the same thing. Over here, this thing is a molecular compound. But we don't use the di, tri, and mono when we're talking about the whole thing, the whole car, the ionic compound. We only use that when we're talking about what's inside the car, the molecular compound right in here. All right, so we do not use di when we're talking about the whole car. We only use di or mono or tri or whatever you have there if we're talking about what's inside the car, this molecular compound in here. Now, most of the time, you're not going to use mono, di, tri at all. Most of the things that you're naming don't have an issue with mono, di, or tri in the molecular compound, in the polyatomic ion. Okay? So I hope my car analogy here helps you to figure out why we're not going to use di ever for the positive ion here, for the ionic compound as a whole. Okay, I think that's it. Thank you. Bye.